Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 7.5 and 7.6 guided notes on three-dimensional figures and cross-sections. We're going to be working more in our next unit with area and perimeter of figures. We're going to be working with volume and surface area of three-dimensional figures as well. So this is really just an introduction that's going to tie into some concepts from our next unit. So a lot of the first page is really just some key concepts, some pictures, and talking about identifying our three-dimensional shapes. So a plane is a two-dimensional flat surface that extends in all directions. You'll learn a little bit more about planes when you take geometry at the high school level, and you'll actually draw them. You'll talk about things that intersect planes and so forth. When planes intersect, they can form three-dimensional figures, or solids. You've probably been learning about three-dimensional figures since elementary school. I know even my son's kindergarten class, they start to talk a little bit about three-dimensional figures. So you should be familiar with some of these already. We're going to start by talking about polyhedrons, and those are solids with flat surfaces that are polygons. So we do have ones that have curved surfaces like cylinders and cones, but we're going to start with our polyhedrons. So all of the surfaces are flat. We're going to be identifying the faces and edges of our three-dimensional shapes, our polyhedrons. So a face is one of the flat surfaces, one of the planes that makes this up. So this appears to be a cube or maybe even a rectangular prism. The faces are, if you think of a six-sided die, the faces are all of the squares on each of the sides. There's 6 faces for this shape. The vertex is each of the places where your planes intersect in a point. So you have a total of 8 vertices for this three-dimensional shape, the 4 here in the front and then the 4 in the back. The edges are the lines that make it up. So I know a lot of times when we do this lesson, students love to practice drawing three-dimensional shapes. It'd be something that when I would doodle in class as a kid, I would often doodle three-dimensional shapes. I'm also a math teacher, but even people who aren't math people love to doodle three-dimensional shapes like cubes and things like that. So a cube like this, or a rectangular prism, its edges, there's actually 12 of them. There's 4 around the top. It's the lines that you draw when you're drawing those shapes. We've got 4 along the bottom, and then you have another 4 that's connecting your 2 parallel bases. So those are your edges. Those are the lines that you draw to create that three-dimensional shape. We're going to start by talking a little bit about prisms. Prisms are polyhedrons with 2 parallel congruent faces. So you have 2 bases in this case, and they're parallel to each other. That is a key component of a prism. They have to have 2 parallel, congruent, meaning same size, same shape, faces, and we call those bases. A prism is named by the shape of its bases. So if we call something a triangular prism, its bases are triangles. If we call it a rectangular prism, its bases are rectangles. If we call it a hexagonal prism, it has 2 bases that are hexagons, and so forth. I do want to mention that in English, the word base typically refers to the bottom of something. That being said, like if you talk about the base of a lamp, for example, that's the bottom. That's what it sits on. When you look down below at the very bottom of this first page, this is a triangular prism right here that I have my highlighter on. Just put a yellow circle above it. This one's a triangular prism, but it's not actually, the bottom of it's not a triangle, but it's still a triangular prism. It just depends on how we have it oriented or how we have it sitting. In this case, it's still a triangular prism. You have 2 parallel bases that are shaded here that are triangles. It does not have to be sitting on the base. That's really important for us, okay? So let's identify a few types of prisms. So on the 2 that we're going to focus most of our time on will be triangular prisms and rectangular prisms. So a triangular prism has 2 triangular bases, and I did draw arrows to point to your bases for this one, and then here the bases are shaded. And again, it's not sitting on the bases, but it still is a triangular prism because you have those 2 faces that are parallel to each other. And since we're calling it a triangular prism, it has to have bases that are triangles. I want to point out that a triangular prism is different than a pyramid. We'll talk about that. It looks a lot like a tent, like a traditional tent that you would set up to go camping. A rectangular prism has 2 rectangular bases, which can be any 2 parallel rectangles. I typically do name the bottom and the top, but you could list the left and the right or the front and the back as your bases. But any 2 parallel rectangles will work for your bases of a rectangular prism. This one's kind of considered a box. Keep in mind something is not a cube unless all of your edges are the exact same length. And it doesn't appear to be that here. We don't really know about this shape. Oops, I have to go back a slide. We don't really know about this shape right here. It looks to be a cube, but we don't have any guarantees that it's definitely a cube. All right, I do want to mention, is this down here? Oh, here it is. Okay. On the top of your next page, I wasn't able to fit this on the same page. I did just show an example of a pentagonal prism, which has two parallel pentagons, and a hexagonal prism, which has two parallel hexagons. So again, you're going to have two parallel faces that are considered the bases. Everything else, by the way, will be rectangles. You might notice that all the other faces, all the other flat surfaces will be rectangles. We're not really going to do a lot with pentagonal or hexagonal prisms, but I did want to show you what they look like. A pyramid is a polyhedron, all flat surfaces, with one base that can be any polygon, and we name it based on its base again. The other faces, by the way, will be triangles. Remember how we just saw with our prisms, all the other faces were rectangles? For a pyramid, all of the other faces will be triangles. So the ones we're going to spend most of our time on will be the triangular pyramid here that's on the left, and really any of those triangular faces could be considered a base. I'm going to use the one that is on the bottom here as the base, but all the other faces are going to be triangles as well. And then we have our rectangular pyramid here. It could be a square pyramid, but again, we don't know that this is a square on the bottom. So to be safe, we'll just call it a rectangular pyramid. The base is a rectangle. The other faces are triangles. Also notice how pyramids go up to a single point at the top, unlike the prisms did. We have an example of a pentagonal pyramid. We could have a hexagonal pyramid, octagonal pyramid, or so forth. Now, I do want to spend some time, and I want you to pause the video, and I want you to think about this. It says, what is the difference between a triangular pyramid and a triangular prism? Think of some differences. There's more than one. All right, I hope you've taken a chance to think of some differences. Let me go with my first difference that I have. A triangular pyramid goes to one point at the top. A triangular prism does not. So remember that triangular prism kind of looks like a tent, which has like a triangle in the front and the back, and then it sort of stretches in between there. So you go to a single point for a pyramid, not for the prism. The non-base faces of a triangular prism are rectangles, whereas the non-base faces of a triangular pyramid are triangles. And then probably the biggest difference is that a triangular pyramid has one base, and a triangular prism has two parallel bases. Sorry, I should fix that in real time. So a triangular pyramid has one base, a triangular prism has two parallel bases. So two bases for any prism, one for a pyramid. That's probably the most important difference. All right, let's talk about some solids that are not polyhedrons. A cylinder is a solid with congruent parallel bases that are circles. It's kind of like a circular prism. You have parallel circles, and then actually the other surface, if you think of a soup can, if you could take the label off of there and lay it flat, it would actually be shaped like a rectangle, interestingly enough. So you can kind of think of a cylinder as a circular prism, and a cone as like a circular pyramid almost. So it goes to a single point at the top, and you have one circular base and one vertex there at the top. All right, so we're going to begin with our first set of exercises. These are a little tedious, and you may have to pause as we're going through these. I know the lines aren't very long, so you may need to write kind of small to fit everything on those lines. You're not going to have a lot of this on your test, but I think it's something that's important for us to be able to do, to name solids and then name their key parts. So we're going to name the solid, its base or bases, its faces, edges, and vertices. So in number 1, often students want to call this a cube. I would be careful. We don't have any guarantees that all of the edges are the same length, so I'm just going to call it a rectangular prism to be safe. When we go to list our bases, choose any two parallel faces. So I'm going to name the bottom, which I'm going to highlight in yellow here, and the top as best as I can. So these are going to be my bases here. Now, when you name the rectangular bases, you have to go either clockwise or counterclockwise, but you can't just skip around. So if I want to name the top, I can't say PMNQ, but I could say PNMQ or PQMN. And are you thinking, do I have to start at P? No, you can start with Q. QPNM or QMNP will work. So let's see how I listed them. So the bottom I started with TSRU. You could also say RUTS for rut. That's some sort of word, I think. So we've got ruts. And then we've got PNMQ. Faces, we have to list those bases again. So we list TSRU and PNMQ. We also are going to list our other faces as well. So we've got NPTS, like this. I actually named it as PTSN. We've got MN, SR. Fix that there. Lots of things to type in, easy to make those mistakes. So we've got PTSN, MNSR, we have MRUQ. Let me go ahead and highlight that. It's a little tricky to do. So MRUQ, that's going to be this face over here outlined in green. And then we have PT UQ. So that's going to be this face back in the back. So notice how I kind of like to outline them as I go so I make sure I include them all. But you should have a total of 6 faces for any rectangular prism or a cube, which makes sense because you have a 6-sided die, so you're going to have 6 faces. The one thing that's really important is make sure you name your bases again as well, because they're also considered faces. So I listed my bases again, you can see that, and then from there just list your others. And again, make sure you have MNSR. I accidentally had MNRS. I must have gone through those too quickly as I was typing them in, so make sure you have that fixed. All right, and then our edges, we'll go ahead and name our edges. There are 12 of those, and I do like to kind of outline these as we go. Let me slide this down. We did, or I did, you'll notice, put little bars over top of each of these to show that they're segments. If you don't put those, you're not going to lose points or anything, but I do want to be technically correct because they are considered segments. So let me go through these as they're written. I'll highlight them in blue. So we've got MN right here. NP, and double check, make sure I didn't make any typos. We've got PQ right here, and then QM as well. So I listed the ones around the top, just kind of went around there. Then from there, looks like we've got TS, SR, RU, and UT, so all the ones along the bottom. And then the ones that connect your two bases. So I started with PT, and then we had NS, MR, QU. And again, you can put those letters in whatever order you want. So this is what makes it really difficult as teachers to check this, because I could have MR, and someone else could have RM. They're the same. So it doesn't matter which order they go in. It becomes even more difficult when we're listing your bases or your faces as well, because these could be in a completely different order. Like I said, some students will put ruts because, like, for example, a truck could create some deep ruts in the ground. So they like to spell words and so forth. So you can put these in a different order as long as you're going either clockwise or counterclockwise. For the edges, you can just put those letters in any order. So it's not really a difficult part to the lesson. There's just some new things with the format and how we write it here. So our vertices, and we can list these in any order we want. I just went M, N, P, Q, R, S, T, U. Just separate them with a comma. All right, let's take a look at number 2, because these are kind of time consuming. What kind of shape is number 2? Hopefully you recognize this guy as a triangular prism, not a triangular pyramid. Our bases then have to be triangles. We do typically put the triangle symbol in front of them. If you don't put it, again, you're not going to lose points. Just go either clockwise or counterclockwise, which you have to do with just 3 letters anyway. So I have FHG for the top, JLK for the bottom. Students really like to put JKL because of, like, just kidding. I don't care which order you put them in. as long as, again, you're going either clockwise or counterclockwise, especially for your rectangles. So for our faces, we need to list those again. So let me just kind of highlight what we have here. So we have FHG, which is the top. That's one of our bases. We've got JLK, which is the bottom down here. And then we have 3 rectangular faces. So let's see which one I listed first. We've got HGKL. That's going to be this like right-hand side over here. And then we have FGKJ. That's going to be the front, FGKJ. So that's the front here. And then the last one is FHLJ. And I want to go around these and make sure I put everything in the correct order. That's the left-hand side there. Now for my edges, I'm going to go ahead and erase my yellow highlights here, and we'll change the color that we're going to highlight this into blue. There are 9 edges here, so we have 3 around the top, 3 around the bottom, and then we've got 3 connecting them. So FH, HG, GF, JL, LK, KJ, and you're probably going to have to pause the video at some point, which is okay. And then the ones that connect them, looks like I have GK first, FJ, and then HL. So all 9 of those. And then for the vertices, super easy, just FGHJLK, and they can go in any order you want. All right, so our next 2. Let me get to it. There we go. Number 3, we have another triangular prism here, not a triangular pyramid, but this is a triangular prism. And even though it's not sitting on the triangular base, when we go to list our bases, they are the 2 triangles. So I named DEF first, so I'll highlight this in yellow. That's going to be this guy, which again, they can go in any order, so you could put Fed if you want to, since it spells a word. And then we have triangle ABC back here in the back. The bases also happen to be right triangles. We'll talk about that a little bit more in our next unit as we go to do some problems. To list our faces, list those 2 triangular bases again, and then our 3 rectangles. So I'll highlight those in green. We've got ADFC, which is the one that's the slant. Kind of looks like a little bit of a ramp, right? So ADFC is this one. We have ADEB, which is going to be this one that's on like the right-hand side. And then the last one we have is going to be the one that's on the bottom. I listed that as BCFE. So BCFE there along the bottom. Go ahead and erase that so we can take a look at our edges. Just like our last triangular prism, we have 9 of those. So go in an order that makes sense so you don't miss any. So I'll do these in blue. We've got AB, BC, CA, DE, EF, FD, and then the ones that connect them. So it looks like we have CF, BE, and AD. Finally, our vertices, I put them in alphabetical order, A, B, C, D, E, F. They can go in any order you want, though. Number 4 is not a prism this time. I'm going to call it a rectangular pyramid. We don't know that that base is a square, even though it kind of looks like it might be. We don't want to assume anything. The base in this case is the rectangular base. That's going to be this guy I'm going to highlight in yellow. And then we'll name it. There we go. Not a very straight line there. But we've got ADCE. And then for my faces, I have to list that again, but I have 4 triangles as well. So let's go ahead and highlight those. We have BCD, which is along, is along the right-hand side. So what happens when I'm trying to highlight with the little, my laptop mouse pad here. We've got BCE, which is back in the back. Let's see if I can make that a little straighter. There we go. That's this guy. We've got BEA, which is going to be this one along the left-hand side, and then BDA, which is going to be the one that's sort of in the front, depending on how you're looking at it, of course. Sometimes it's hard to see that. Those dotted lines are meant to be the ones that are back in the back that can't be seen. All right, let me erase that so we can identify our edges. We have, I think, 8 of these. We have the 4 from the top down, and then we have the 4 around the bottom. So I'll highlight those in blue. We've got EC, CD, DA, AE. We've got the ones that connect them, so BD, BC, BE, and BA. So yeah, we have a total of 8 of those, and our vertices are just A, B, C, D, E. All right, we'll continue to see a little bit more practice with that. I realize that it's kind of a new topic for you, identifying these things. It's not going to be a major part of your test, but I think you have a multiple choice question where you identify the shape and maybe identify its bases. The reason why identifying, I think the most important thing is identifying the shape and identifying the bases, because we use the bases to help us find volume and surface area. So that's why we talk about it in this lesson. All right, let's talk about skew lines. This is something that I don't know if it would show up on like a PSSA kind of test, but a few years ago it was some random topic they threw into 7th grade standards. And so I added it into the notes, and it's not a bad idea to talk about it, just kind of visualizing things in 3 dimensions. But skew lines are lines that lie in different planes and they do not intersect. This is different than parallel lines, which do lie in the same plane. So if we have a rectangular prism like this, the lines that are shown that I'm going to highlight here in yellow, these are skew lines. They're never going to intersect. Now, in 2 dimensions, if I extend this line right here, it's going to eventually intersect this. But if you imagine, and usually when I teach this in person, I imagine the room that we're in, the classroom, and we don't have to imagine it because it'll be right in front of us. But if we have the front edge going across the front along the top of the ceiling there, and then we envision one of the back walls going down vertically, those are never going to intersect each other, and they are in different planes as well. Now, if we have the front top edge along the ceiling going across the front, and then the one along the bottom going across horizontally, those would be parallel. So in the classroom, when I talk about that, like this green highlighted segment here and this green highlighted segment here, or this one down here, those would be parallel to each other. They happen to lie in the same plane. Or even this one across the back here and then this guy down here would be considered parallel because they would actually lie in the same plane if I created a diagonal plane that went from like that back edge to the front bottom edge. So it can get pretty complicated, and I'm not good at visualizing 3-dimensional shapes. In fact, I honestly think that a lot of you might be better at visualizing that too. It is easier if you can envision the classroom or you can be in a room that's sort of a box shape, because it helps you to kind of see which ones are parallel, which ones are never going to intersect. Because in 2 dimensions, it kind of looks like they will. So in number 5, let's talk about this a little bit. This is not on your test, but I know this is something you'll see in the future. So it says in the figure at the left, we've got a rectangular prism. FM is a diagonal, like we can have on a 2-dimensional shape. We can also have in a 3-dimensional shape. We want to name 3 segments that are skew to diagonal FM, so they're never going to intersect. We don't have any that are parallel in this case, so that's not really going to be an issue. Sometimes I have students who try to list JG, and as long as this is a rectangular prism, I don't think they'll intersect. But I wouldn't list one of the diagonals here. What I would do is just list segments that are given as edges of this figure. So here's what I listed. Now, I gave more than 3, I gave 6. But here we have FM, which I'm going to highlight in green. And I gave KL as one of those that's never going to intersect. Now, in 2 dimensions, they appear to intersect. But keep in mind, this is going through the box. This is on the back edge of the box, so it's not going to intersect. I also listed JK back here, never going to intersect, even in, well, I guess it would intersect if I continued it this way, but if you envision this in 2 dimensions, or 3 dimensions, they're never going to intersect. We've got LG over here. We've got EJ, which is this one right here. EH, which is this one, which again in 2 dimensions appears to intersect right there. But again, this is going to be the front of the box. This green line is going through the box, so not going to intersect. Then my last one I had was HG. I think I listed all of the edges that would be skew. You can't list any edges that include either F or M because those will intersect. So I've had students try to list, let's say, FG. Well, it's going to intersect at point F. So we want to make sure that these segments do not intersect. And then it says, are KL and EH parallel, skew, or intersecting? So let me erase this here. Let me highlight these segments in yellow. So KL is going to be this one. EH is going to be this one here. Now, they don't appear like they're ever going to intersect, so they're not intersecting, that's for sure. But we want to figure out, are they parallel or skew? So we want to determine, do they lie in the same plane? Not as drawn here, but I could create a plane that sort of slices through this thing. And we're about to see this with our cross sections of three-dimensional shapes. But if I imagine slicing through this, starting at EH and going down to KL, I could put them in the same plane. Whereas again, like if I had EH and GL, there's just no way to put them in the same plane. So these would not be considered skew, they would be considered parallel because again, they could lie in the same plane. So speaking of planes slicing through three-dimensional figures, let's talk a little bit about cross sections. So in class, we're going to spend a little bit of time watching a short video clip that talks about cross sections and how to create those. There's also some really cool websites out there where you can take a three-dimensional shape and slice it in different ways, like vertically, horizontally, at a diagonal, and see what the cross sections look like. Because again, I think that's sometimes difficult to envision. I know in tech ed, one of the things you guys typically do is draw like of a three-dimensional shape, the front view, side views, the back view, the top view, and so forth of those. So those of you who feel really comfortable with that might feel pretty good about this. Those of you who felt a little uncertain about that, which would have been me in middle school and high school, might feel a little bit more uncertain about this, and that's okay. I will tell you that the questions that are on your test related to this stuff are pretty straightforward and simple, so it's nothing crazy. I'm probably going a little bit above and beyond in this video, showing you some of these different cross sections. So here's the thing. Interesting shapes occur when a plane intersects or cuts a solid figure. And you can kind of see those bold lines in these figures below is where we're slicing through these three-dimensional shapes. And we'll watch that in a video in class. I'll link to it as well, not in the video here, but on the weekly agenda. So the intersection of the solid and a plane is called a cross-section of the shape. So what we kind of have to envision here in number 6 is a horizontal slice would be like slicing through this thing, like taking a knife, or in the example we've got, or the video we've got some ninjas slicing through. So if you slice through this thing, imagine pulling off this top piece and then looking down at the shape that you see, or looking at the shape that you see when you pull that slice off. We want to envision what kind of shape we're going to see. It's going to be a two-dimensional shape that's created. What do you think we're going to see if we would slice through this thing horizontally, we pulled off that top, and you looked down at what's left? What shape would you see? And again, we're talking about a two-dimensional shape. Well, we're going to see a square. So all of the sides are going to be congruent here. And again, this is a square pyramid, which is how we know it's a square, because it specifically states that. Let me go ahead and highlight that word, that phrase in yellow. That's going to be really important for us. So this is a square pyramid. If it were not a square pyramid, we'd see a rectangle, but you're going to see, again, a four-sided quadrilateral shape, in this case, a square shape. It's going to be the same shape as your base, just a little smaller. And depending on where you slice this horizontally, if you slice it closer to the top, it's going to be a smaller square. Closer to the bottom, it's going to be a bigger square. All right, let's talk about a vertical slice. Now, this one almost looks like it's at a diagonal, but typically we slice through this thing vertically, a lot of times through the vertex. Imagine pulling like this piece off of here, opening it up. What shape would you see on either end? Again, a two-dimensional shape. If you're thinking triangle, you're correct. You should see a triangle on either end. So if we slice this thing horizontally, the shape you're going to see is shaped like the base. Slice it vertically, it's kind of going to look a little bit more like your faces, your other faces, I should say. An angled slice. What do you think that's going to look like? So maybe we start our slice closer to the top of this triangular pyramid and then end closer to the bottom. We could go really crazy if we slice this, sort of at a diagonal too. I mean, we can really go crazy with these things, or so that maybe the slice goes through the bottom instead of somewhere through the shape as well. We're not going to go crazy with our slices. We're going to try to keep it pretty easy. The angled slice, though, is a little bit more complicated. What shape do you think we're going to see? If you're thinking a trapezoid, you're correct, because when we slice closer to the top, it's going to be more narrow, and finish our slice closer to the bottom, it's going to be wider, but they are going to be parallel to each other. So it's going to look like a trapezoid. And again, if you're like, I don't know, this is kind of weird, Mrs. Garcia, that's okay. This is something we're going to spend some more time on, and it's not going to be a major part of your test. I don't want you to freak out too much about it. It's something you'll see a little bit more of even into our next unit. All right, let's take a look at number 7. A carpenter wants to cut a cylindrical tree trunk into a circle, an oval, and a rectangle. How could the tree trunk be cut to get each shape? How do you think we could slice this thing to get a circular shape? You sometimes see these. These are used often as like decorations for country weddings and things like that. You want to slice this thing horizontally or parallel to the base. So we're going to kind of cut through it sort of this way. So we're going to slice through this like this. Once you slice through it, you're going to be able to see on the top and the shape that you pull off as well as on the bottom, you're going to see a circle. Let's talk about the rectangle. How do we need to slice this to get the rectangular shape? Lots of talking for this one. We want to slice through this thing vertically. So if we slice from top to bottom like this, and we imagine opening this thing up, we're going to see a rectangle on either side. And what about if we want to get an oval shape? So if we want to get an oval shape, this is where we want to slice horizontally at an angle. I guess you could say sort of almost vertically as well. It's sort of between horizontally and vertically. But if you slice through this thing at an angle, you're going to get sort of a stretched out circle. So it's going to look a little bit more like an oval. So imagine taking this thing and slicing through it like this. You're going to end up with a stretched out circle, which will look more like an oval. All right, number 8, Carolyn has a cake pan shaped like half of a sphere. So I drew this out. I actually left this from before so that I could show this to you because I knew I wouldn't be able to construct this as easily, but it's going to look kind of like this, a half sphere. Describe the shape of the cross sections of cake baked in this pan if they are cut horizontally and vertically on its base. So we could sit this way so it looks more like a bowl. We could put it face down as well, but right now I just made it look a little bit like a bowl. It's still a half sphere. So if we slice this thing horizontally, so slice it across here, what do you think the cross sections are going to look like? If you said circle, you're right. Generally, when we slice horizontally, it's going to look like its base. So if we're slicing parallel to the base, then your cross section is going to look like the base. Depending on where we slice this, it could be a bigger circle or it could be a smaller circle. What if we slice through this thing vertically? So what I mean by that is actually slicing through it like this. What do you think that shape's going to look like? If you're thinking a semicircle or a half circle, you're correct. So imagine pulling this across, you're just going to see a half circle. So you're going to see a flat surface across here, and then it's going to be a round surface right towards the bottom there, which again is a little hard to envision, I realize. All right, number 9. A deli slicer is used to cut cylindrical blocks of ham for sandwiches. Suppose a customer wants slices that are round and slices that are rectangular. Picky customer. How can the deli ham be placed on the slicer to get each shape? So if we want to get those round slices, we're going to slice this thing parallel to its base. So actually the way it is right here, if you're taking this thing, this part moves and slides across, then you're going to be able to get your round slices, which we can kind of see popping out the bottom here. If we want to get those rectangular slices, instead we're going to slice perpendicular to the base. So imagine taking this thing and putting this, the part that's towards the slicer, putting that face down on here and then sliding it across. You're going to start to get rectangular shapes in that case. Or if we took this, looks kind of like bologna down here, stick this on there with the circles on the bottom, start slicing across, you're going to get those rectangular slices. Now, numbers 10 and 11, 12, and 13, I think are pretty close to what you're going to see on your test. So if you were kind of panicking about this lesson because you're like, this is weird, I don't get it, it's hard, look at numbers 10 through 13. Your problems on your test, or problem on your test, I don't even think you have much, are going to be pretty similar to these. So number 10 says, determine the shape resulting from each cross-section of the cone. So imagine this blue plane slicing through your cone here. What shape are you going to get? If you're thinking triangle, you're correct. So if I pull this thing off, you're going to get a triangle on either side. What about if we slice this thing horizontally? If you're thinking the shape's going to be a circle, your cross-section, remember, is a two-dimensional shape. It's going to be a circle in this case. I do want to mention, I'm actually going to point out 10A here. Sorry, I was getting distracted. I can hear my kids upstairs. But in 10A, I often have students who think this is definitely going to be a triangle, but I have students sometimes who think that it's going to sort of look like two straight lines going down, and then the bottom is a curve. Let's see if I can make that. So they almost think the bottom's going to be curved like this. It's not going to be, because keep in mind this is meeting straight across along the bottom here. There would be like a straight line going through here, and so you would see this sort of being your cross section here. So it would be a triangle, not something that's curved at the bottom. All right, number 11. So we've got a rectangular prism here and we're slicing through. Again, imagine if you took this blue plane and just kind of slid it up through, and what would be like the cutout that you'd have in the middle? Well, you'd have a rectangular cutout. So your cross section would be a rectangle. We've got a triangular prism here. This is kind of confusing when you slice it horizontally like this, but it's also going to be a rectangle. Excuse me. If you slice it closer to the top, it's going to be a smaller, like skinnier rectangle. Closer to the bottom, it's going to be a wider rectangle. Now, this one, when we slice this rectangular prism, vertically in this case, it's going to be parallel to this front that we have, which happens to be a square. Those tick marks indicate that. So that means that our cross section or our slice is going to be shaped like a square. And again, imagine like this was actually cutting through this blue plane. If you pull this blue plane off of here, the cutout would be shaped like a square. If we pulled it off of here, the cutout would be shaped like a rectangle. Here, the cutout would be shaped like a rectangle. So that's a good way to envision what your cross section would be. All right, so we covered a lot of different things in this lesson, from just identifying three-dimensional shapes and their parts to identifying what cross sections look like. You're not going to have a lot of this on the test, but it is setting the foundation for our future work in our next unit as we go to work with volume and surface area of three-dimensional figures, and also looking at area of cross sections as well. So it's definitely a good foundational lesson, even though there's not a lot of it on your test. So of course, if there's questions about this stuff, feel free to check in with me during class as well, but it's something we'll spend a little bit more time and watching a video as well on cross sections in class. Thanks for listening.